So far in 0011 we met lots of built-in Python types, including dictionaries, lists, tuples, integers, floating point numbers, and so on. But it often happens that you want to make your own type. The way that we do this in Python is via what's called a class. Mostly these are useful for representing data which doesn't fit well into one of the built-in types, especially complex data made up of several different parts. But there's also another reason to create classes. When we represent data in a program, we often want special operations suitable to that data and only that data. And we'd like to represent those operations in a natural and easy way, which is both easy to use and easy for people reading our programs to understand. For example, let's say you want to work with vectors in Python, so ordinary mathematical vectors, and you decide to represent the vector xy with a list containing the numbers x and y. Well, okay, that's easy enough. We all know all about lists. They're already built in, and it's quite simple to see the correspondence between these lists and vectors. But probably you want to do some kind of operations on your vectors. For example, the most basic thing you might want to do is to add them together. But if you do the list xy plus the list zw, that's not equal to the list x plus z, y plus w. You remember that what plus means for lists is concatenation, so you get the list of length 4 containing x and y and z and w. So of course you can get around this. You can write a function add to take two vectors represented as lists and return the list which would represent the vector sum, whose elements in my previous example would be x plus z and then y plus w. But it's slightly inconvenient to have to do so, and it makes it easy to introduce accidental errors in your program where you forget and use the plus sign, which won't give you the vector addition. Similarly, let's say you wanted to work with sets in Python, and you might choose to represent a set containing 1, 2, 3 as the list containing 1, 2, 3. But then you have another confusing problem, which is that the list 1, 2, 3 is not equal to the list 2, 3, 1, whereas the set 1, 2, 3 and the set 2, 3, 1 are equal. So you have a problem, which is that you need to then write your own functions for set equality and set inequality, and be careful always to use them when you're working with list sets represented as lists. Now actually there's already a built-in set type in Python, so this isn't a real issue, but you can see here the kind of problem which might arise when you're representing your own data using built-in Python types. So let's look at an example of building our own type in Python. And remember, when we create our types in Python, we do these using what are called classes. We're going to make a class to represent a UCL student. Each student will have 3 pieces of data about them stored in this class: their name, their student number, and the subject that they study. Those are called instance variables, because a particular object of our new type representing a UCL student is called an instance of the class of UCL students. Now, there is a slightly weird way to create instance variables for a class. And in fact, the syntax for classes can look quite intimidating to begin with. So you will have to get used to some strange looking syntax, but hopefully the meaning of this syntax will become clear. There's really nothing horrible happening here, but it just looks a bit confusing to begin with. So to define a class, which we're doing in this code cell, we begin with the keyword class, and then we put the name of the class. So on line 1, I'm starting the definition of a new class, and the name of that new class is UCL student. To end the line beginning with class, I have to have a colon as usual, and then as usual I have to indent everything that's part of the class definition by 4 spaces. If you want to create instance variables for instances of your class, so that's the data associated in our case to a UCL student, which is going to be their name, their student number and their subject, they have to be defined inside a special function whose name is __init___. So that is compulsory, unfortunately. This function is something which is called automatically when a new instance of the class is created. And the purpose of init is to set up the instance variables for an instance of this class. The arguments to this function are also slightly confusing. The first argument to the init function represents the new instance of the class being created, and traditionally we call it self, although it's not always. It doesn't have to be called self. There's no reason it has to be given this name, but traditionally we use the word self because we're referring to the actual object being created. Any subsequent arguments to the init function have to be supplied by the user when they create an instance of this class. So here, when somebody creates a new UCL student, they're going to have to supply the name, the student number, and the student subject. So inside our definition here, what we do is we assign the student name supplied by the person creating a student to the variable name self.name. And similarly, we assign the student number supplied by the person creating a new UCL student to a variable called self.number, and the same for the subject. What this does is create 3 instance variables called self.name, self.number, and self.subject, with the values supplied by the person creating a new student. They can then be accessed using the same dot notation, which we're going to see in a moment. So let's get on and run this cell so that the class has now been created, and in the next cell we're going to create a new student. So the variable name A will refer to this new student, and the way we have to create them is by using the class name as if it were the function init, and then supplying 3 arguments. So this might look a bit confusing because the init function took 4 arguments, but remember the first argument refers to the new student being created. So we supply 3 arguments in order: the student name, the student number, and the subject they study. You can see this has worked fine. And now I have a new UCL student referred to by the variable name A, and with the 3 properties which I supplied when I created that student. If I now want to access the name and the student number and the subject that the student studies, I do this with the notation a.name to get their name, a.number to get their student number, and a.subject to get their subject. You can see that when we do this, we recover the 3 variables which were supplied when we created the student in the code cell here. So this really does look a bit confusing to begin with. So let's just run over some of the things about this class definition which need an explanation. When the new student, which is referred to by the variable A, was created in the code cell right here, the init function gets called. Self in the init function refers to the new student being created, in this case the student who's referred to by the variable A. When we set self.name equal to student name, what we were doing is creating a new instance variable, which we can get using a.name for our student referred to by A, and giving it the value alpha, which was provided as the student name when we created the new student. So this is how class creation and instance variables works. Now, as well as creating instance variables, classes can have their own functions, which are called methods. Those are functions which work only with things of type the new class that we've created. We're going to give an example where we define a method for our UCL student class, and the method will make the student say something. So here is the same class definition as before, up to line 6. But in line 8, I define a method. A method is a function which belongs to this class and which can be called on any instance of the class. So here we define our method, which is called speak, and we do this with an ordinary function definition inside the definition of the class. So as usual, we use def and then the name of the function speak, and then we give it one argument self, which refers to the particular UCL student that this method belongs to. All that speak does is print something out to the screen. So you can see here what it prints out is a concatenation of 4 strings. Remember, the plus operator for strings just glues them together, puts them next to each other, or concatenates them. So it will print out my name is, and then self.name, which refers to the name of a particular student. Then it says I study, and then self.subject, which is the string which represents the subject the particular student studies. Once we've run this redefinition of the class so that it now has this speak method, we can call the speak method on our UCL student objects using a similar dot notation that we used to get instance variables. So if I create a new UCL student whose name is Alpha, whose student number is this, and whose subject is mathematics, then we can call this method speak using a.speak, and then a pair of empty brackets here. And you can see that it does what it was supposed to do. It prints out my name is Alpha and I study mathematics. Now again, there's something really weird happening here because I defined speak to take a single argument. Right? It took an argument which we called self. But the way I've just called it is with no arguments at all. I just had brackets and then nothing between those brackets. So you should think of this call to a.speak with no arguments as meaning speak brackets a. That's because the self variable, when we declared the function speak, refers to the particular student whose speak method is being called.